Hi, it's John from Communication House. Okay, we've got an Alinco DX-70. This is the TE, which is the early one, I think. I'm not a great historian on radios. It's coming with a number of faults. There was a broken coil on this. It was on the other side. That's the PLL board. And it wasn't receiving. Also, there was no transmission. Now, I sorted the coil out. I managed to locate one from the Alinco UK supplier. But there's also a problem with the transmission. And I basically checked. They've checked the RF was all correct going to the PA board, and the filter board was okay. And the problem was clearly on the PA board. Now, you see, I've got the PA board out. You can see this burn mark here. So if we come over, this is the PA board. It uses a pair of 2904. See that? Devices, and you can see I've lifted the collectors up. Now what's happened is, if we look down at the back there, put the light in there, you can actually see the boards burnt, and if we turn it over, see the track has burnt out. Now, basically what's happened is, these devices, or one of these devices, has gone. I've got the circuit diagram here. It's basically how this unit works. The PA, it uses 2SC 1971 as a pre-driver, a pair of 2SC 1972s as the driver, running in parallel in a balanced circuit. That's these transformers. And then we've got a little switch there, a relay, and that just literally switches these transistors directly to the filter board. That's for running in 6 meter mode. So if you run 6 meters, this unit will only give you what these can deliver, which is, I think to the book's probably about 4 or 5 watts. You probably get more out of them, but that's how it's been designed. But in HF mode it carries on, and these act as a driver rather than a final, and you've got these 2904s, the Mitsubishi devices, and as I say, one of them's gone short, and as that's gone short, what's happened is, if you look here, if you look, they've got common emitters there, but if we look on this side, you've got centre tap on this transformer, which is this unit here. It's being fed up. There's the outputs. This is the actually 13.8 volt rail. Sorry, this is here, and that's basically a choke, and that feeds that transformer. So if one of these goes short, and you see they're common emitter and they're tied to earth, so if one of these goes short, there's a mass rush of current, and something has to give, and in this case, you can see the board's gone. Now, this is repairable. I've tested these two 1972s here and here. They're working okay, and the 1971 pre-driver, they're okay. The reason they've used 1972s in this, because they're a VHF transistor, and these all run up to sort of 100 I think the book, I can't remember, but I think the paper says about 175 megs they're good for. You probably get more. So normally in an HF set you would use something like 2SC 3133s. Well, this is the PA board. I've repaired it and we'll find something to point with. Here's the probe. You can see where the track was burnt. I've actually put a piece of solid core wire there. It's a leg off an old resistor. It's one of the old types, so it's quite heavy. And this here is a bit of hot melt glue, which will hopefully hold it still and stop any vibrations. Now, to be honest, I wouldn't normally repair a board with this much damage on it. However, I've sort of explained to the customer that you know, if you know, it's fixable. You know, it's not unrepairable, but you know, I don't like doing it. It's a mess. And if you have a look at the board when it went, see that there. See the board's swollen. It's really gone. I've tested everything. It all seems fine. Also, that wire, which comes off the 13.8 volt supply rail, basically, well, via this resistor, which I've also replaced, which is R629, which is a 4.7 ohm 3 watt resistor. Now, this is more hot melt glue, so I put in there. Again, if it's used in mobile operation, or you've got to make them reasonably rugged so they'll withstand the withstand shock and vibration. Okay, we see I haven't installed the transistors yet. I've got a new pair of focusing 2904s. Here, there's a little letter on them there. I can see that. E. And that's the HFE classification. I've got the data sheet for this, and it doesn't give the HFE classifications, but normally it's something like between 180 and 240. And these are the old ones. I've gone short circuit, and this has got an F on it. It doesn't matter. I mean, I'm not worried about the HFE, just as long as they're the same. And even though one of these is still working, I'll be reluctant to run it. Now, the next thing to do with this is obviously this needs to be installed back into the unit prior to fixing these transistors in. So the first thing to do is reinstall this. Okay, before I put the board in, I'm going to put some silicon thermal transfer grease on basically the chassis. It's just a machined piece of aluminium. If you look at these raised areas here, they've been machined. There's another one there. That's where basically the power transistors on the board make contact with this cast aluminium chassis, and obviously it dissipates the heat that way. If we look on the board here, we've got these two SC 1972s. Now, these don't need insulation kits because they are common emitter, and the way they're designed, these go to ground anyway. And this is completely insulated transistor, so there's no need for insulation on these. But what they do need is some thermal transfer grease, silicone grease. I'll basically put a little bit on, not too much, so it will spread out by itself. I'll do the main transistors when we actually install them. I personally, the bane of my life is silicone grease. Okay, now it's time for the main power output devices to go in. I'll just curl the lid slightly down, I don't know if you can see that. The reason I do this is just so that when it goes in, you know, they're pushing down. So if they're, they won't bend down because you can't take them far enough. That's the sure they go in the correct way. That's the base there. So it comes on the collectors go on that far side. Okay. Let's do a bit of silicon. Too much because it gets into absolutely everything, this stuff. Okay, well, I've cleaned up the excess flux, and I've actually run a fibre pen between them as well, just to get rid of any residue. But HF, it's not that crucial, and also these are bipolar devices, so it's what you really do have to watch with VHF, UHF, field effect, FET. MOS devices, they're very susceptible and to such a high impedance. Flux residue it's a big no-no because they'll stop them working properly. They even go into self-oscillation. But they're in. Okay, well, the next thing, I'm just going to put all the assemblies back together. There's also a 1970 one there that needs a mounting kit put in on it, so I'll put it all back together, and then there's a filter board to go in on the top, ready for testing. Okay, well, we've got the unit back together, and we'll just summarise. We've replaced, you can't see them now, but we've replaced the final devices, we've repaired the tracks, and we've also checked the other components. Now it's installed. Now before we go any further, I think we just need to go through a few things. Okay, I think I've got to cover a few points here. I'm not making this video as a tutorial, but if you are working on a PA and you're not experienced at doing it, there's a few things that you have to consider, and I think I'd rather you sort of learn by mistakes made in the past, and including myself. A classic way of blowing up RF output transistors, they're quite powerful devices, but they're also quite delicate. It's people putting probes onto the circuit board. Look here, there's a layout. Yeah, they put probes on. Where are they? Here we go. People put probes on their boards and be a bit clumsy and short. Short the pins out, and that doesn't do them any good at all. So if you use a probe, use a very fine tipped probe. So I always use very fine tipped probes for that very reason. Another thing to obviously consider is in standby mode, these devices, if we look there, the collectors are connected to either side of this transformer. The centre tap is connected directly to the power supply, the 13.8 volt supply, and on the other side of the transistor the emitters are common together to ground. So as soon as the power is actually plugged into the radio, whether it's switched on or off, you've got a potential here between these devices. And if we look here, there's two 10 ohm resistors which are from the base of each transistor, which is both common to ground as well, to pull the bases low. Now, where a lot of people go wrong, if these are blown, there's a good chance that the bias drive device may have either played a part in it blowing up or blown at the same time. And what happens is, if this switch is on, because that comes off a 13.8 volt rail, that transistor is switched on. It's an emitter follower circuit, this, and basically supplies the base of these transistors. Now the idea is, once the transistor, what happens is this bias drive is controlled by this rail here, which is the transmission 8 volt rail. So it's a DC switch rail which just goes from 0 to 8 volts when you key the mic. When the mic goes into, you press the PTT button. Now, you've got these two diodes here, which, because of PN junctions, you will only get a maximum of the combined potentials of those two devices, which will be about 1.2 volts. Now you've got a variable resistor here which will adjust the basically what it'll do, it'll start switching this transistor on, and obviously because you've got 1.1 volts here, you expect to see about you've got a PN junction there, so you're going to get a 0.6 of a volt drop. So the voltage is going to be stabilised at around 0.5, 0.6 of a volt at that point, and the current control is done by this this resistor here. this variable resistor, which is a pot. Now, the reason this is done is two reasons. A, it'll put the it'll switch the PA into an on state, and secondly, under if there's no carrier being amplified down here, it goes into what we call an idle process, an idle status. So, and you can control the current. And what you need to do with these devices, we bring the idle current up to it's only a low level, and it just means that this circuit will work in a linear fashion. And if this isn't correct, your sidebands won't. If your transmission in sideband transmissions, you know, they won't be linear. You know, for wherever, if it's not set correctly, if it's set the threshold's too high, you'll be losing bits of you could possibly lose bits of your transmission. If it's too low, it just goes washy, the waveform, if you look at it, and again, you'll get distortion again. So it's critical that that's correct. Now you need to check these. This is what a lot of people don't do. The PA blows up, they think, I found the parts, blah blah blah, we'll change them. You know, put those in, but they don't consider this, and this is the most important part. If you take those diodes away from that circuit and then put this into transmission mode, i.e. keying the mic, these will just switch full on. They will just go completely full on. They will draw as much current as your power supply will let it. And if you've got a fuse in line with on your power lead, you know, maybe a 20 amp fuse, but or 25 amp fuse, but you've also got a short burst of you know, you've got a lot of current coming down here, and it will just wreck these devices. You know, and this is obviously under DC conditions, so it's vitally important that these diodes are generally connected to, they're actually mounted above the devices so that the bias will actually track with the temperature. So as these warm up, because obviously the characteristics of bipolar transistors, you know, well, as most semiconductors, they change as they heat up, and because they're doing a lot of work and their inefficiencies, they do generate heat as a byproduct. And these are designed to operate at the same temperature, and therefore the bias should track and stay the same. And it's the same on the driver stage. If we come back, it doesn't need so much current, so it hasn't got a direct switching drive transistor. But again, you've got a pot here. Again, you've got your diode there, which is basically is strapping the voltage down, and in this case it'll be about 0.6 of a volt. If you look on the drawing here, you can see the diode is mounted directly above one of the devices. It doesn't need to be both of them because they're running in parallel, and they'll exhibit the same amount of heat dissipation. So that's why it's only on one device. Now, once that's all checked and that's all working properly, then, you know, you should only then consider to bring the you know, put power on it and make sure it's correct. And obviously there are settings, if you look in the manual, which I'll go through, which are primarily just to set it's called the idle currents. It's a biasing. You see, you bias in these transistors, and if we look here again, you know, it's the same with the driver stage, you know, and there's a link here. You can actually remove a link there, and it even tells you on there, look, you adjust in an idle process, i.e. you be in sidebands with any sound and, you know, no carrier, and you'd expect to adjust onto your managing that pot there, and that will give you, you set that to 100 milliamps, and that's the operating range, bias range of that stage, to keep it linear. And there's also certainly, it's all in the manual there. There is another transistor here on the final. That's just acting as a hard switch, and basically what that does is, when it runs in 6 meter mode, that switches on, pulls the base of the bias drive device low, which will stop the current flowing, and this relay clicks over as well, and then in 6 meter mode it will transmit up this rail, using these transistors as the final. This is a pretty typical PA. If you look at a lot of PAs, they don't vary much. They suffer from the same problems. They've all generally got these devices. If you've got field effect transistors here, you'll find that the bias drive is slightly different. They're generally not such heavy transistors, so they don't have to do so much work, because obviously they get the input impedance on field effect transistors is a lot higher, and the characteristics of how they work is different, but we won't go into I'm not going to go into that just at this point in time. Okay, right, well, let's move on. I bring the power on, but I'm not going to use a conventional power supply. I've got this bench power supply here. Just just a little bit away. I can turn that down a touch. That'll do. Okay, now this is current limiting. The current limiter is completely off, so we're not going to. The radio switched off. It's connected. So I'm going to bring this around. I know obviously it depends for different power supplies, but I know this one. So if I bring this up to that current up to 12 o'clock, that will give me about 900 to 1 amp. I've brought it up and it's not drawing any current, which is a good sign. The idea is obviously we've got current limiting, so we brought it up. We haven't got a short circuit. I'll just ensure we've got, carefully, these are very fine tip probes onto the collector there. We've got 13.5 volts. So we know that power's there, which is good. Okay, well the next step is to actually switch the unit on. Okay, so as you can see, someone's obviously been using this on the 11 meter band. That probably figures why there's a problem with it. No, I shouldn't say that, but it's okay. Well, I'm going to put it into SSB, so I'm in upper sideband, and the RF level, which is high-low, is already. I'm going to leave it in the low position. I'm going to key the mic. Okay, it's drawing 980 milliamps. Obviously there's no carrier going through it, which again is a good sign. If there's a problem, that switches on hard, there's probably a biasing problem. If I put it into transmission mode, look on here, that's the bias drive transistor, and I'll put that on the emitter again. Fine probe, 5.45 volts. That's what we'd expect to see, so I'm happy that that's okay. Now I'd always check this when rebuilding a PA to make sure everything's okay before you actually put the main current on there, because if you put it on a large power supply, I mean the power supplies here, we've got them that will deliver 60-70 amps and without any protection you can imagine what it'll do. Okay, well, it's all back together. Well, as it can be. I've obviously got a screw. It still needs the cases need to go on, but I've tested the transmitter. The PA's all working. What I have found, because obviously PAs are quite, they're quite robust, and if they've not been played with, and obviously watch your SWR. I mean, these have got protection in them as well. The PAs should last. It's generally through misuse that they go, and it's just a false economy drawing more power. Now, obviously, we know there was part in the filter. There was a part gone causing the filter board to switch incorrectly. So that obviously may have played a part. But for that diode to go, generally what makes those go is excessive RF in the board. Now I've brought this up, I've got it running, and if you watch this, watch on the power meter, obviously this is a scale to 150 watts. We're on low power at the moment. I'll just bring it up to high power. Watch this. I just did it briefly. This thing was running, will go up to, those transistors will run 180 watts, no problem. They won't last very long. So someone's obviously been in here and been meddling with it, obviously to get more output power. Consequently, that's what's, I'm guessing, but that's what's blown the PA. So the first thing I'm going to do, because we're currently on transmitting on FM, by the way, and we're on top band 180, 160 meters rather, and that's what it's pushing out on a deck carrier. So we're going to have to bring that back. So I'm now going to adjust. There's a pot on here, VR7. So I'm going to go through, and I suspect it's all been meddled with, so I'm going to go through and realign those now. Okay, well, we've got the voltage on the power supply, which is quite crucial, set to 13.8. And I've adjusted the power, so she's just doing just a tad below 100 watts, which is correct. I don't believe in overdriving these things. Okay, well, I've gone through it. I'm going to screw it together now, and we'll see if we can, I can give it an air test. Someone's clearly been in it. I mean, I don't know. Yeah, it's got the wrong screws in here and stuff. I mean, people ruin radios, it's a sad thing, but it's true, there's a lot going on in here, and it just makes my job absolutely makes more difficult, but having said that, it keeps me in work, so I can't knock it too much, but okay, well, let's get this together.
do you think, Daddy?
Well, I reckon we've nailed it.